July 1970. Firebase Ripcord, Northern R Corps. A hilltop clearing, 280 meters of wire, and 43 men who hadn't slept in 30 hours. Beyond the perimeter, triple canopy jungle so dense it swallowed sound. No visibility, no warning. Just the certainty, not the fear, the certainty that something was moving through the trees toward them. 68 devices sat along the tree line, each aimed outward at chest height, each connected by copper wire to a man with his thumb on a detonator. The soldiers didn't have to be faster than what was coming. They didn't have to be more numerous. They didn't even have to see it. They just had to press a button. In the previous episode, we documented what the National Liberation Front built into the ground itself. Punji pits that forced 30 to 40% reduction in patrol speed, cartridge traps producing gunshot wounds from buried ammunition, tripwire grenades averaging 2 to 4 casualties per activation, and buried artillery shells that broke unit cohesion for 72 to 96 hours. Between 1965 and 1972, these devices killed approximately 11,000 American personnel and wounded 70,000 to 90,000 more. A systematic terrain denial program that made every footfall potentially lethal and transformed the ground into a weapon that could not be engaged, located, or decisively defeated. The United States Army's doctrinal response was not improved mine detection. It was not revised patrol formations or protective equipment. The response was a weapon that operated on precisely the same principle the Viet Cong had perfected: invisible, instantaneous, activation controlled by the defender. The difference was physics. Where an NLF grenade trap projected fragments to 5 meters with a 4-second fuse delay, the American system projected fragments to 50 meters with 0 delay. Where a buried artillery shell created a fixed kill zone the attacker chose to enter, the American system created mobile kill zones the defender chose to activate. The device was designated M18A1. Common name, Claymore. And it changed the mathematics of who controlled the night. The Claymore was not designed for Vietnam. Its operational origins preceded the conflict by 15 years and addressed a tactical problem the jungle war would later replicate under different conditions. November 1950, Korean Peninsula. Chinese People's Volunteer Army crossed the Yalu River and within weeks executed coordinated mass infantry assault doctrine against United Nations defensive positions. The attacks came at night, in waves, exploiting gaps in perimeter wire and overwhelming defensive sectors through numerical superiority and coordinated movement. Conventional mines, pressure-activated area effect devices optimized against vehicles, proved inadequate. A blast mine detonated when stepped on, producing spherical fragmentation that radiated in all directions equally. Against a coordinated assault wave moving through a perimeter breach in darkness, this meant most of the explosive energy was wasted on empty ground, while attackers in the kill zone received only a fraction of the total fragment density. The Army needed a mine that could produce directed, immediate saturation of a frontal arc, a weapon that turned explosive force into a wall of metal rather than a sphere of it. The solution came from Norman McLeod, a civilian ordnance engineer at Picatinny Arsenal, New Jersey. McLeod had been investigating shaped charge principles since 1947. The same physics that focused explosive energy into armor-penetrating jets for anti-tank warheads. His innovation was geometric inversion. Instead of concentrating energy into a narrow penetrating stream, distributed across a wide horizontal plane. Instead of defeating armor, saturate an area with fragmentation. The curvature was critical. A convex face ensured fragments converged at optimal range rather than dispersing spherically and losing density. The prototype, designated T-48, emerged in 1954. Ballistic testing at Aberdeen Proving Ground demonstrated lethality to 50 meters and casualty production beyond 100 meters. This was 5 times the effective radius of defensive hand grenades and triple the range of existing fragmentation mines. The Army standardized the design in 1960 as the M18 mine. The name Claymore was retrospective infantry terminology referencing the Scottish broadsword, appropriate for a weapon that functioned as a directional blade of steel rather than an omnidirectional explosion. Korea ended before large-scale deployment. The Claymore entered inventory as a specialized defensive munition with limited distribution. Then came Vietnam, and the weapon found the environment it was engineered for, though not in the way its designers had anticipated. The M18A1 measures 216 millimeters wide, 83 millimeters tall, 35 millimeters deep at the thickest point. Weight, 1.58 kilograms. The housing is fiberglass reinforced plastic, chosen for corrosion resistance in tropical humidity, lightweight portability, and electrical non-conductivity. The front face curves outward. The rear face curves inward. This double curvature transforms the device from a container of explosive into a geometric focusing lens. 700 steel spheres, each 3.2 millimeters in diameter, embedded in epoxy resin and bonded directly to 680 grams of C4 plastic explosive. The spheres are not randomly distributed. Their spacing and arrangement follow calculated patterns optimized for fragment dispersion density at 50 meters. Initiation occurs at the rear center via an M4 electric blasting cap. The explosive front propagates forward at 8,050 meters per second, approximately 24 times the speed of sound. As the detonation wave reaches the fragment matrix, it accelerates the steel spheres to roughly 1,200 meters per second. The curvature ensures these projectiles converge at 50 meters range, creating maximum fragment density at the statistically most probable engagement distance for perimeter defense and ambush operations. The resulting pattern extends 60 degrees horizontally, approximately the width of a standard jungle trail at 30 meters, and 16 degrees vertically. Within this arc, fragment density averages 2 to 3 impacts per square meter at 50 meters. A standing soldier in the center of the pattern receives an estimated 15 to 20 fragment strikes. At 100 meters, 3 to 5 impacts. Beyond 100 meters, individual fragments retain sufficient velocity to produce wounds, but probability of incapacitation drops below tactical reliability thresholds. Danger radius specifications: 50 meters lethal, 100 meters casualty producing, 250 meters maximum fragment travel, 16 meters. Rear and flank, backblast danger zone. These numbers reflect ballistic testing against human analog targets measuring statistical probability of incapacitation, not theoretical fragment trajectories. The distinction is operationally significant. The Claymore was engineered around casualty production rates, not maximum range. The warning molded into the plastic housing, front toward enemy, exists because American soldiers died from improper orientation during training and early operational deployment. Between 1961 and 1964, 17 documented fatalities resulted from Claymores positioned backward. The device's symmetry created confusion in darkness and under stress. The solution was human factors engineering. Mold directional text into the housing itself. This modification reduced orientation errors by approximately 90%. The phrase became iconic, but its existence reflects a design vulnerability that killed Americans before it killed enemies. The inscription is not irony. It is operational necessity encoded in plastic. But the inscription introduced a second vulnerability. NLF sapper units, the Viet Cong, identified the directional text as an exploitable weakness. The tactic required no explosives and minimal noise. Locate the firing wire, follow it to the mine, disconnect the blasting cap, rotate the device 180 degrees on its bipod legs, reconnect. The next time an American soldier pressed the firing device, 700 steel balls detonated directly into the position the mine was designed to protect. The weapon's defining strength, directional precision, was also its most exploitable characteristic. American units responded with anti-disturbance attachments and irregular emplacement patterns. The Viet Cong had forced defenders to complicate their own access to their own weapons. The device carried a second inscription that has generated disproportionate cultural attention. Warning: explosive is poisonous if eaten. This was not theoretical. C4 contains RDX, which produces stimulant effects in small quantities. Soldiers facing exhaustion and inadequate resupply had discovered this, and field medical records document the consequences. The Army's response followed the same logic as the directional text. Encode the warning in the device itself. By 1967, the M18A1 appeared in virtually every dimension of American ground operations in Vietnam. Its applications fell into three distinct doctrinal categories, each with different effectiveness profiles and tactical constraints. The first was perimeter defense, standard employment for fire bases and patrol bases. A typical company perimeter, 200 to 300 meters circumference, received 20 to 40 claymores positioned at 8 to 12 meter intervals along defensive wire. Each mine aimed to produce overlapping coverage with adjacent devices, eliminating dead ground where attackers could maneuver without entering kill zones. Firing wires ran back to fighting positions where soldiers maintained manual detonation control via M57 firing devices. Handheld electrical generators producing 5 joule pulses sufficient to initiate the M4 blasting cap. When NLF or NVA forces conducted night ground assault, simultaneous detonation of multiple claymores produced instantaneous saturation of the assault front. Documented engagements during the 1968 Tet Offensive at Firebase Bao Bang and multiple actions around Khe Sanh demonstrated both capability and limitation. Mass command detonation inflicted immediate casualties and disrupted assault timing, but only within the 100-meter effective range. Attackers who breached the Claymore belt entered conventional small arms engagement zones where the mines offered no further protection. The second application was ambush operations, the Claymore's most tactically effective use. Platoon-level patrols positioned 4 to 8 devices along likely enemy movement routes, all connected to a single firing point. When the target element entered the designated kill zone, simultaneous detonation produced immediate fragmentation saturation across the engagement area. 4 claymores, approximately 2,800 steel balls accelerated to supersonic velocity in overlapping 60-degree arcs. The physics eliminated the need for extended firefights. After-action reports from 1967 to 1969 consistently documented that NLF forces encountering Claymore ambushes did not execute the tactical withdrawal and maneuver responses observed in conventional engagements. The fragmentation arrival was too sudden and too complete. Surviving personnel in the kill zone were typically incapacitated by fragment wounds, overpressure trauma, or psychological shock within the first 2 seconds. The ambush, historically a tactical form requiring sustained fire to achieve attrition, became an instantaneous event. The third application returned the Claymore to the asymmetric framework of its NLF adversaries. Attached to tripwire rather than command detonation, the M18A1 became a passive anti-personnel device functionally equivalent to the grenade traps that ranked second in the NLF trap arsenal. American forces began employing tripwire claymores along infiltration corridors and perimeter margins in the same systematic terrain denial role the NLF had used so effectively. The tactical irony was precise. A weapon designed to counter mass assault was being deployed as an area denial booby trap, indistinguishable in operational concept from enemy systems. The M18A1 succeeded in Vietnam for the same fundamental reason NLF improvised devices succeeded. It exploited the asymmetry between attacker and defender in an environment where the defender controlled engagement location and timing. The NLF trap program achieved its effect not through any single device, but through systematic creation of an environment where every terrain feature was potentially lethal. The cumulative psychological weight of sustained mine threat exposure degraded American combat effectiveness. Soldiers developed neurotic behavioral patterns. Patrol speed decreased. Point man assignment became a source of unit friction. The Claymore provided operational reciprocity. It imposed the same psychological calculus on NLF forces operating in terrain American units controlled. A firebase perimeter saturated with claymores forced NLF assault planners to treat American positions the way American patrols treated suspected mine-dense jungle. As environments where the ground itself could kill without warning in fractions of a second from weapons invisible until detonation. The Claymore was not invincible. Determined infiltrators could locate firing wires through systematic ground searches and cut them, neutralizing entire defensive sectors. Sophisticated attackers employed suppressive fire against likely Claymore firing positions immediately upon contact, disrupting operator coordination. More fundamentally, the weapon's effectiveness depended entirely on proper employment. Correct positioning, adequate camouflage, and disciplined firing control. Poor emplacement or premature detonation squandered tactical advantage. The 60-degree horizontal arc meant that even optimally positioned claymores created coverage gaps. Attackers who identified mine positions could maneuver around the kill zones using terrain features and approach angles outside the fragmentation pattern. The 16-meter rear danger zone constrained placement near friendly positions. The requirement for line of sight from firing position to target area limited effectiveness in dense vegetation where visual confirmation of enemy presence was impossible. Extended defensive operations revealed operator fatigue as a critical vulnerability. Command-detonated weapons required a human maintaining vigilance to initiate firing at the correct moment. During multi-hour darkness periods, attention degradation was inevitable. Documented incidents show both premature detonations, wasting devices on false contacts, and delayed detonations where operators hesitated or failed to recognize target presence until assault forces had already breached the effective kill zone. Between 1966 and 1973, American forces deployed an estimated 5 million M18A1 Claymore mines across Southeast Asia. The weapon became standard equipment at every operational level from squad fighting positions to core-level firebase networks. It saved thousands of American lives by preventing perimeter penetrations and reducing ambush casualties. It killed tens of thousands of enemy combatants in engagements where American forces controlled timing and location. But tactical effectiveness did not resolve the strategic problem. The previous episode documented how the NLF trap program succeeded not by killing sufficient Americans to compel withdrawal, but by degrading the psychological sustainability of infantry operations over time, by making the ground an enemy that could not be engaged or defeated. The Claymore gave American forces equivalent capacity. It did not eliminate asymmetric warfare. It made asymmetric warfare mutual. Both sides had weaponized terrain. Neither could disarm the other's version. The result was a combat environment where every defended position was potentially catastrophic to assault, and every patrol route potentially catastrophic to traverse. The Claymore forced NLF units to approach American-held ground with the same caution and fear American infantry brought to every trail in every province of Vietnam. The ground was never neutral. The M18A1 made certain both sides knew it.